In a world overflowing with images, from social media to surveillance footage, medical scans to satellite photography, understanding and interpreting visual data has become essential. This is where machine learning steps in, revolutionizing the way computers see and interpret the world. But how does it actually work when applied to image recognition? Let's explore this fascinating journey where pixels become patterns and patterns become understanding. Imagine teaching a child to recognize a cat. You show them various pictures, point at each one and say, "cat." And gradually they start to notice features: pointy ears, whiskers, furry bodies. Machine learning works in a similar way. Instead of manually programming a computer to look for cat-like features, we give it thousands of labeled images and let it learn from them. This approach, known as supervised learning, forms the foundation of most image recognition systems. The magic begins with data. In image recognition, data comes in the form of images, millions of them sometimes. Each image is essentially a matrix of pixel values. For a grayscale image, each pixel is a single number representing brightness. For color images, each pixel has 3 values corresponding to red, green, and blue intensities. These numbers don't mean much on their own, but when combined in the right way, they can reveal edges, shapes, textures, and ultimately, the identity of what's in the image. To process these numbers, we use algorithms, complex mathematical models that adjust themselves based on the data they see. One of the most powerful tools in image recognition is a type of neural network called a convolutional neural network, or CNN. CNNs are specially designed to work with visual data. They mimic the way the human brain processes images, starting with simple patterns like edges and lines, and gradually building up to more complex structures like eyes, faces, or objects. At the heart of a CNN are filters, small matrices that slide over the image to detect specific features. Think of a filter like a tiny stencil that highlights vertical edges, or maybe detects circular shapes. These filters generate feature maps that emphasize important patterns in the image while ignoring irrelevant details. As the image passes through more layers of the network, it's distilled into the most essential features for classification. Once the model has been trained, meaning it has adjusted its internal parameters to minimize error, it can be used to make predictions. Show it a new image, and it will output the likelihood that the image contains a cat, a dog, or any other object it was trained on. The more data it has seen, and the better its architecture, the more accurate it becomes. But image recognition isn't just about identifying objects. It can also involve detecting faces, recognizing handwriting, analyzing medical scans, and even understanding scenes. For instance, in facial recognition systems, the model doesn't just detect that a face is present, it compares it to a database to find a match. In medical imaging, machine learning models help doctors detect tumors or classify diseases with incredible speed and precision. Despite its power, machine learning and image recognition faces challenges. Lighting conditions, occlusions, variations in angle, or even biased training data can lead to errors. That's why ongoing research focuses on improving model robustness, fairness, and transparency. Techniques like data augmentation, transfer learning, and model interpretability play a key role in addressing these issues. In real-world applications, image recognition has become indispensable. Self-driving cars use it to detect road signs, pedestrians, and lane markings. Smartphones unlock with a glance thanks to facial recognition. Retailers analyze customer behavior through surveillance footage, and social platforms automatically tag friends in photos. The possibilities are expanding every day. As we move forward, combining machine learning with other technologies like augmented reality, robotics, and natural language processing will only deepen its impact. From identifying rare species in the wild to helping the visually impaired navigate the world, machine learning for image recognition is more than just technology. It's a new way for machines to see, understand, and interact with the visual world around us.